right, y'all. Welcome in to the world of fractions. That is right. We are going to dive into fractions and start talking about like what are they, who are they, what happens, how do we do them, and all this other great stuff. So I'm really excited about this. It's a really good start. I think just to kick off, we're going to start looking at what are the differences between these two different terms. We'll start to see this idea of like what makes a fractional set, and we'll talk about that, and what makes a fractional part. Right? So, you know, fractional, that's just fancy terms. We are just talking about fractions. So like, how do we look at fractions as parts, and how do we look at fractions as sets? And you're probably already saying, well, I don't even, what do you mean by even a fraction, right? And that's okay. I'm going to show that as we get into this. So let's go ahead and start. We're going to just like chip away at all this stuff. Let's start with fractional sets. So let's dive into a fractional set. So if we look at this word set, it's the idea of like a group of something. So let me just give you an example. I'll make a set. Let's see, I'm going to go here, 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 back to here, and let's do this. Okay, so here's my set. This is my set of information that I have here. Okay, so here's the set. It's like a group of something if we want to think about that. It's like a group. And if I look at this, I'm going to build a fraction. Now, a fraction has three parts, and we'll talk about some of the parts. So I don't want you to like panic as I throw a lot at you, but it's going to have what we call like a fraction part here, and then it has a numerator, and a denominator. For the sake of now, it's got a number on the top. It's got a number on the bottom. I'm going to allow that in the beginning, but we will definitely start using the vocabulary words, right? So if I'm going to build this fractional set, I first have to look at like what is in my set. Like what is in this group? How much do I have all together? So let's just count all the stars we have, all of them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so I'm going to start by getting rid of this bottom number, this denominator, because that is actually what tells us the total. The denominator is all the pieces in the group, and in this case, we have 10, okay? So that's what a denominator is. It's the total. The denominator is the total. So we have 10 stars. So then someone might ask the question of like, what is the fractional, like, what is the fraction of, let's do purple stars in this case, right? So what we're going to do is we're just going to go look at the purple stars. We have 1, 2, 3, 4. And that's what we read as our numerator. Our numerator is like, what's the thing that we have, right? There's a total of 10 stars. 4 of them are stars. So that's the, when someone says, oh, what's the fraction of stars from this set? Well, it's 4. Someone might actually, purple star, excuse me. Someone might actually also ask, okay, well, what's the fraction of yellow stars? Okay, well, the total doesn't change. I still have 10 stars altogether, so there's my denominator again. And then I just want to look, well, how many are yellow? I have 1, 2, 3 yellow. So the fraction of yellow stars from this set is 3 out of 5. I mean, 3 out of 10, excuse me. Woo. Okay, so let's like look at another fractional set. So again, a fractional set would be just like a group of something. Let's do this. I'm not gonna go by color this time. Let's go by the whole group of some polygons of some sort, or actually, yeah, some shapes maybe. Let's do like a big old rectangle. Okay, so let's just start there. So here's my set, right? Here's the set. Here's the group of things. And the first thing I need to figure out is like, what's my denominator? All right, we're going to push that word today, denominator. So again, that's the total in the set. That's all of it. So we're going to need our little fraction line here. And let's just look at how many total shapes there are. There's 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there's 9 total shapes. And so then you just start asking questions of like, okay, well, let's write the fraction of like how many are, let's say, well, how many are squares, right? Okay, well, let's look at the squares. We have 1, 2, 3. So my fraction of this set, right, of this total amount of squares is 3 out of 5, okay? Let's ask how many are triangles. So again, my total hasn't changed. The total in the set is still 9. And how many are triangles? Well, we have 1, 2, 3. So there's that, right? And maybe we want to ask circles. Whoa, circles. That's going to be still 9. And we see there's 2 of them. Okay. All right, let's do one more example of a set. And this time I'm going to do a set of numbers. So there's our set, right? So a fractional set. There's our group. So we have this whole set of numbers, right? Remember, that's the total. And then we're going to start asking questions to make fractions out of that. So let's just start by finding our denominator, because we'll do that before we even know the question, right? The denominator is the total number of pieces in our set. In this case, my set is numbers. It's not shapes or colors or anything. It's just numbers. So let's look at how many numbers there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my denominator is 10, right? That's the total of it. That's my set. All right, so then questions come along. So what's the first question we want to ask? We might want to ask the question of how many numbers are the number 2 in this set? So we know there's 10 total numbers. Well, let's go count how many are 2s. There's 1, 2. There's 2 2s. So there's our numerator. That's 2. So that tells us the fraction, right, of this set that are 2s is 2 out of 10. 2, 2. That's interesting. You could ask other questions out of this data. Like, let's look at our fractional set here. We have all these numbers. Again, we know we have 10, so our denominator doesn't change. We still have 10. And maybe in this case, the question might be, well, what is the fraction of odd numbers in this data, right? Like, what do we see in this set of numbers that are odd? And remember, odd is when you start at the number 1 and you skip count by 2. So like 1, 3, 5, 7, 9, 11. These are odd numbers. So let's go look for our odd numbers up here. Let's see, 9 is an odd number, 7 is an odd number, 7 again is an odd number. So in this case, my fraction from this set of numbers, my fraction of odd numbers is 3 out of 10. Okay, so that's what makes a fractional set. It's the idea that you have a group of something and then you're looking at answering these questions about them. Let's talk about the other part, and that's fractional parts, right? So a fractional part. Fractional part is probably the most common one that you see, right? Fractional parts are these ideas of you actually start not with a whole group of things, but with just one whole. You start with one single model. And I think the most common way and the easiest way for any of you to always model this is just use a square or rectangle. It's like there's one that I think easiest way to partition things and look. So here's my whole, right? Okay, and then what we're going to do is we're going to partition this. We're going to cut it into parts, and we got to cut it into equal parts. That's so key. Everything's got to be equal. So I'm just going to cut it into equal parts like this, right? And then let's just look at this model and ask, well, how many parts did I cut it into, right? This is fractional parts. How many parts does it cut into? Well, we have 1, we have 2, we have 3, we have 4 parts. That's the total. There's a total of 4 parts, so that's my denominator. So my denominator is 4, because there's 4 total parts. And then someone always comes along and says, okay, well, I'm going to shade in some of these parts. And I'm going to ask you, what's the fraction of shaded parts, right? Parts, again, here's the parts. How many parts did I shade it? Well, I shaded 1, 2, 3. So my fraction is 3 out of 4 parts of this whole are shaded. That's my fraction. So let's look at another fractional part. So we're going to take another model, right? And you can model it anyway. I really find these are best. Like, you could use a circle, but I always find circles are kind of hard to cut into equal parts, especially if maybe you had to cut it into like 10 pieces. That might be pretty hard. And rectangles, those are pretty hard to cut into equal parts too, because look, those parts aren't even the same. So that's why I stick with this piece here. Let's go ahead and I'm going to partition it. So let's stop and look at this and say, all right, well, how many parts, right? What's my denominator? How many parts have I partitioned my whole into, right? And this represents the whole. It's all of it. It's one big thing, not like a hole in the ground. That's not what we're talking about. That's a different kind of hole. We don't want that. We want this hole. So we have 1, 2, 3 parts. So there's the denominator, the total. It's the total number of parts. And then again, someone is always going to be like, oh, well, what is the fractional part, right? What is the part that's shaded in? Well, I see 1 part shaded in, so that's 1 out of 3. Okay, so let's just do one more model like that, a fractional part. Let's talk about fractional parts. So I'm going to take a whole, right? That's what this is. It's the whole. Okay, and then we're going to partition it, meaning I'm going to cut it into equal parts. Let's do this. Okay, let's go ahead and get our denominator. Actually, before I even do that, I'm going to shade first, because sometimes we're not going to be so lucky that we may end up just with something like this first. Okay, so now let's get our denominator. Now that the whole model has been partitioned, it's been cut into parts, and it's been shaded. So our denominator, remember, that's the total. It's all the pieces that it's cut into, and that's the bottom number. So we're just going to look at all the pieces, shaded and not shaded, all the total pieces. So we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total parts that this hole has been cut into. And then the question is, well, how many have been shaded green, right? So let's go count how many have been shaded green. We got 1, 2, 3, 4, 5, 6. So our numerator, our top number is 6. There's 6 out of 8. And you might even ask the question, oh, how many are not shaded, right? Well, in this case, there's still 8 total parts, and we see that 2 are not. 2 out of 8 are not, okay? So that's what we're looking at when we talk about fractional parts and fractional sets. So again, fractional parts is one whole model and it's cut, and then you have something shaded. So in this case, there's 4 total pieces, 1 is shaded. A fractional set is a group of things where something might be different, right? And you ask the question, well, of the set, 1, 2, 3, 4, 5 pieces, so that's the denominator, the 5 pieces, how many are stars? Oh, 4 of them are. So that's 4 out of 5. So this is, oh, sorry, this would be set. Let's put in that keyword. So this is really that difference that we look at. Like, what is the difference between how we model fractions as parts and how do we model fractions as sets? We're continuing to work on this. Don't worry. I appreciate your hard work. There'll be more to follow. There'll even be more before this. So we keep asking questions. We keep working hard. And as always, thank you so much for all of your hard work.